So question 5 is a little bit different than the previous things we've been graphing because this is vertex form. And what we can easily find from vertex form is the vertex. So we want to know, what is the vertex? Well, the x value is going to be the number with x, but it will have the opposite sign. So we see here inside with x is -2. So that means the x value is +2. And the y value will be the number that's always being added or subtracted outside of the parentheses. So we have a +3 here. So 3 is going to be our y coordinate. So we have our vertex at 2, 3. It's right here. And we know that the axis of symmetry runs through the vertex, so I can create my axis of symmetry right here. However, unlike the standard form, it does take a little bit of math to find the y-intercept. So we need to plug in 0 anywhere we see x and solve for what y would be. So 0 minus 2 is -2 squared plus 4. Well, -2 squared is 4, plus 3 is 7. So my y-intercept is at 7. And with our axis of symmetry, if I have a point 2 away from the axis of symmetry here, I have 2 away here. And now I can connect my points to draw my quadratic. All right, we'll pretend like that I actually connected. All right, this is also, again, in vertex form, so it's pretty simple to find the vertex. Your x-coordinate of your vertex is the number with x, so it's 1. We keep the opposite sign, so it says -1 there, but it's really a +1. Your y-coordinate is the plus or minus number that's outside of it, so that is -1. So I can plot my point at 1, -1. And I have the axis of symmetry that goes down through the vertex. Now I have to do some math in order to be able to find the y-intercept. Again, we're going to plug in 0 anywhere we see x. So 0 minus 1 is -1. Squared is just +1. So I end up with 2 times 1 is 2. Minus 1 is 1. So I have a vertex, or I have a y-intercept at 0, 1. And if I have a point 1 away from the axis of symmetry there, it'll be another point on the other side of the axis of symmetry. Now I can connect my points to draw my parabola. This is also in vertex form. However, we noticed in the past it's had like x minus a number, and that was part of our x coordinate. There is no number there, so that actually means that our x coordinate is at 0 for the vertex. And then the other number, the -4, that would be our y-intercept, or the y point. So in this case, the y-intercept and the vertex are one and the same. We can draw our axis of symmetry. It'll be down the y-axis there. Since the vertex and the y-intercept are the same point, we're actually going to need to pick another value for x in order to figure out what this looks like. Now, you can pick any number. However, let's think we want it to be able to fit on our coordinate plane. So keep it small. So either 1, 2, 3, a couple of those. I'm going to pick 2. I could pick 1 just as easily though. So f of 2 is 2 squared minus 4. Well, that is 4 minus 4 is 0. So I have a point at 2, 0. So it's right here. And again, with the axis of symmetry, if I have a point that far away from the axis of symmetry there, then I have a matching point on the other side. Now I have 3 points, and I can draw my quadratic. Question number 8 is f of x equals x squared. This is the most basic form of a quadratic. We don't have a plus or minus or anything that goes with it. So I know that my vertex is going to be at 0, 0. There's been no shifts. That also means that the axis of symmetry is there. And if you want an idea of like what this looks like, you could plug in a couple of numbers. I'm just going to pick 3. That way it's not too close to my vertex. So at f of 3, I have 3 squared is 9. So I can plug in 3, 9, 1, 2, 3. It's up here. And again, with the axis of symmetry, I have to have another point at negative 3 on the other side here. And I can connect my 3 points. Oh, that went a bit awry. Let's try that again. I connect my 3 points to form my quadratic. Question number 9 is the last example of graphing quadratics. It's again in vertex form. So the vertex, the x value is with x. It's going to be the opposite sign though. So though it says plus 2, it's really a negative 2. Your y value is the plus or minus part outside the parentheses, so minus 8 is your y value. So I can plug in my vertex. It is at negative 2 and negative 8. Right there. Which means that's where the axis of symmetry runs through. We want to try finding our y-intercept, so we're going to plug in 0 for x. So that would be 0 plus 2 is 2, and 2 squared is 4. So we're going to have 3 times 4 minus 8. Well, 3 times 4 is 12, minus 8 is negative 4. So I have my y-intercept is at 0, 4. It looks like it was a negative 4, but it's just past the 4 there. So I'm going to plot my y-intercept. 1, 2. It's right there. And on the other side of the axis of symmetry is another point. And connect them all together. Please check out the other videos for further help on your review.